And so today I wanted to look at the object model in just a little more detail and give you a little better view of what's there and how to use some things that might not be all that obvious and need a little bit of description. So, and again, this is Brian Ekins. I presented at the last one too, and so let's go ahead and get started here. So just a quick overview. This same thing as I discussed last time is we have this object model chart. So this chart's just put together manually, but to give a as a tool to help you get from one object to the other, because the API is organized in this hierarchy. And so to navigate through the API, you have to understand which object owns which other object, and that's how you'll get from one to the other. And so you traverse that to get to specific objects that you want to use in your program. And so let's look at some examples here. So there's a legend on the chart, and let's zoom in on this sketch portion of the legend. And so there was some question about, well, first, so every box on here is an object, but there's some that I'll talk about in a little more detail in a second, but they're called collection objects, and those have these rounded boxes. So we've got all these objects, and some are collection objects. And then there's also this notation with where there's a letter inside brackets and it's bolded, or there's a letter inside parentheses and it's not bolded and in italics. And what that's showing is trying to show here is some class structure. So the object model itself isn't a class diagram. It's showing ownership, but it's still good to know what's derived from what. So this class structure, and that's what this is attempting to show. So for example, I have in sketch curves, there's a sketch curve object, and it has a bolded R, so it's a parent class for everything that has this italic R. So sketch arc is derived from sketch curve, and sketch circle is derived from sketch curve, right? But we can see sketch curve also has this Q in parentheses, so it's derived from sketch entity. So that's what that notation is to try and show some class relationships between the different objects. And then there's just coloring to help you get a basic idea of what's what. So instead of just this big white paper with lots of boxes on it, you can see how they're grouped a little bit just by functionality. All right, so objects, pretty obvious. So they're what you get to that have all the methods, properties, and events that you'll be programming against. So collection objects are another object, so they have methods, properties, and events. But collections, every collection has count and item functions on it. So you can, and a collection is a list essentially of a group of objects, and typically they're a group of a certain type of objects. So for example, there's a sketch lines collection. So if I go to that collection and I get the count, then that would tell me how many sketch lines are in that particular sketch, the sketch that I got that collection from. So count would tell me how many lines are in that, and then item would let me get each of those lines. So if there's 5 lines, I could get item 0, 1, 2, 3, 4, and get each of those sketch lines. And some collections, so every collection supports count and item, and some collections also support one of these two properties, item by name or item by ID, and they let you get a specific object out of that collection by its name. So this should be on all the collections that have objects in them that are named. So for example, features. And so I could go to the features collection and say, give me the thing named extrude 1 or whatever the user's named it. Or I could go to a parameter and say, give me the parameter named length. So instead of having to look through all of them and find the one that has a certain name, I can just use these to get it immediately if it's there, or if it's not, then this will. Right. And collections also support, that's if you want to create something, it's going to be through a collection. So again, that example of sketch lines, if I go to the sketch lines collection, it's going to have some methods that let me create new sketch lines. And if I want to create an extrude feature, I would go to the extrude features collection. If I want to create a joint, I would go to the joints collection. So it's the collections of a specific type that supports the functions to create new things of that type. There's also in the API list objects, and they're a collection also, but they don't ever support creation. So they're used just to return a list of things that, so for example, parameters. So there's two types of parameters. There's model parameters and there's user parameters. And you can only ever create user parameters. Model parameters get created automatically as you're building the model. And for example, if I do an extrude, then there's a parameter automatically created to control the depth of that extrude and the angle of the extrude. And but if I want to look at all the parameters in a document, there is a way to get that, and that's returned as a list of parameters. And so the API goes and looks through Fusion, and it gets all of the parameters, groups them together, and then returns it as a list. And then I can operate on that. So I don't create new parameters through that. There's other collections I would go to the user parameters collection. I would go to create a new parameter, but sometimes things are returned as a list of things. Another example is if I create a rectangle, so that creates 4 lines, and so the return of that creation is actually a sketch lines list, and so then I can get the 4 lines that were just created. There's also an object called object collection. So again, it's a collection object. It supports item and count, and this one is used quite a bit in the API in places where you need to where you're calling a function and one of the arguments requires more than one thing. And let's see, for example, if I'm going to do a fillet and I have 3 edges, then the way I would supply those edges is I first create an object collection, and I would add those 3 edges into the collection, and then I would pass that collection into the method to create a fillet. And so in quite a few cases, you'll have to create an object collection as input, and there are also quite a few cases where an object collection is passed back as a result. So just something to be aware of, that thing exists. And then I mentioned this a little bit the other day. There's also a type of object called an input object, and that's used when you're creating a little bit more complex objects. Like all the features use this, and there's several others too that use it. And this is the best way to think of this is input objects are the equivalent of a dialog. So when I click the extrude command, the dialog pops up to gather the input, and this input object is a programming object that has properties on it that are the equivalent of the things that the dialog is asking the user for. So instead of in the API, instead of having this dialog that you're interacting with to supply the needed input, you have this input object, and you're setting whatever the required properties are on that input. And so you define what's needed, and then you say, okay, now create an extrude using this input, and then it does it. So just some different types of objects. I mean, they're all objects, and several of these are flavors of collection objects, but we've tried to be consistent in the API design so that they're used in a consistent way, and they have a little bit different behavior depending on how they're used. There's one other one called a definition object, and I think maybe I'll hold off on explaining this one until we get to a spot where I can kind of talk about it a little better. So let's look at the chart. And so here we've got this big chart, a lot of objects. I should have counted them before we started this, but there's a lot in there, and just want to go through it a little bit section by section and talk about what's here. So this area off to the left is kind of application stuff. So you can see we've got the application object, and these are all accessed directly from the application object. So that means they apply to really all of Fusion. They're not specific to data in a document or anything like that. They apply to all of Fusion. And so from the application, this first one, this data object and the objects underneath it, so those provide the functionality somewhat equivalent to this data panel. So they let me basically look and see what's on A360 and get the particular, so a data file would be a Fusion file that's sitting up on A360, and then I could open that in Fusion. Or if I create a new file and you need to save it, I'm going to have to go query this to get a data folder that I want to save this file to. So this provides, like say, the equivalent of the data panel. This import manager is essentially the equivalent of this new design from file, although the API supports a little bit more than the UI does. So I can also import into an existing file instead of having to create a new file. This area is to provides access to materials and appearances to those libraries. And then this area, of course, is the preferences. So it's the equivalent of all the information that's in this dialog. And then, so there's user interface objects. That's everything here in the yellow. And this is basically, there's two sets of functionality here. I've got functionality to modify these toolbars. So this main toolbar across here, across the top, where you access all your commands. There's also this toolbar at the top called the QAT, or Quick Access Toolbar. There's a toolbar over to the right, and the one you don't see it here at the bottom that has the view manipulation stuff in it, called nav bar.
I think there is some delay, Brian, about refresh of your screen.
Okay. So I'll just go ahead and keep talking a little bit while it's yeah. So it's been static. Oh, it's been static for a while, so I'm not sure what's taking so long.
You can just talk about the toolbars. It's now I'm able to see your Fusion screen. I'm able to see it.
Yeah. So yeah. Anyway, so there's the toolbars, and through the API, I have really full access to that. So I can query what commands. So with the main toolbar, for example, if I'm in the model workspace, I have a create panel and a modify panel, assemble panel, and so I can look to see what panels are there. I can look and see what commands are inside each panel, and through the API I can add commands, I can remove commands, I can create new panels, I could delete panels. So I have pretty much full access to that user interface. But typically what would be done is through that is that you're going to create custom commands and add your commands into that panel. So like is shown here, this so there's this Addins panel. That's new in this latest release. And so a lot of your commands will likely go in here. And so I've added, this is a command I had, this dialog test. And so I was able to add it into here. So in this UI, so a portion of it is to provide access to all this information, and then a big portion of this that you can see is to support the creation of custom commands, which this spur gear is demonstrating. So it lets you build these kind of custom dialogues to get input from the user and then do whatever you want as a result of that input. And we'll go in, so that the other presentation on Thursday, we'll go into a lot more deeper detail on UI, user interface, and custom commands. All right, this next slide, and it looks like it's slow to come up too for some reason. But have it listed as document and design. And there's this area of the object model where from the application there's a collection of documents. So those are all of the documents that are currently open in Fusion. And then from that documents collection, I can get, say, for example, the active document, and then from it, from inside a Fusion document, then I can get a design. And then from a design, I can get this export manager. So that's the equivalent of this export command. So I can write out the entire contents of the design, or I can do, I think, individual bodies or components, I can't remember, but I can write those out as these different formats. I have access to parameters through this. So you can see there that parameter list where I was talking about. So that's combined all of the parameters in various components and returning them as a list. I have access to the timeline. But what I wanted to talk a little bit more here is this, well, no, I'm going to go into more detail in it later. So this design versus product. So I have something else in a little bit, so we'll go into more detail. So let's just keep going right now. Components and features is the next thing. So just this area of the chart. And zoom in on it a little bit. So again, from a design. So from the document, we get the design. And so that's a one-to-one correspondence. So when I would have a design is when I have a Fusion document open. So the design represents Fusion data in a document. And today, that's all the API supports. So some of this structure doesn't make all that much sense in today's world, but in the future, from a document, I could get the design data, I could get the CAM data, I could get the SIM data, maybe the drawing data. So there's the different types of, the API refers to them as products, but the different things that work inside Fusion to build the stuff, whether it's building a model or building a toolpath, then that stuff that they build is segmented. And so here, when we go to, we get a design, that means we're getting the Fusion data that's inside that document. And so from a design, you get a component. And this component is kind of special because so if we look at the browser, there's always this top node in the browser, and that represents what's called the root component. So that's the top level node and the root component. So it owns, so there's always a one-to-one correspondence between the root component and the design. And so from that root component, then I can get the rest of the data, the design data that's inside that document, right? Which, so from the root component, I can get the physical properties. And then I can get, of course, all of the features. So it's through these collections that I can query the features and I can create new features. And you can see here the derivation. So from I have the features collection, and if I iterate through that, that will give me all of the features regardless of their type. So everything would be returned as a feature object. And so a feature object supports, generic things. So the name, is it suppressed, things like that. And so I could iterate through all of the features and find out, okay, is any feature suppressed, and unsuppress it if it is. But if I care about a specific kind of feature, then I can go to that collection. So I can go to the extrude features collection, and now it's going to give me just the extrude features, and I'll have access to all the information that's unique to an extrude feature. All right, so the next section on here is the bodies in this purple box on the chart. And let's just zoom in on it. All right, so from the component again, so this is so we've got the root component, which has all of this, and then you can have other subcomponents, right? Because inside Fusion, as you're building, you can create new components, or when you create a new feature, a lot of times you can say create as a new component, so then new subcomponents. So I always have one root component, but I can have multiple other components owned by that component. And so this component could be the root component or any of the other components. And within the component, there are these mesh bodies. And what a mesh body is you can use the insert mesh command and insert an STL file or an OBJ file to create basically this mesh. So just a set of triangles that you're able to view inside Fusion and reference as you do your modeling. So that's exposed through the API, so you have access to any meshes that the user has created. And then kind of more important is this BREP body. So that gives you access to the model geometry. And so I can query, for example, this model that we see here, I can query and find out how many faces it has. On each face, I can find out what shape it is. So is it a plane? Is it a cylinder? Is it a NURBS freeform surface? And so I can find out exactly what the geometry of this thing is and how things are connected to. And also, in addition, there's this area at the bottom of the chart that kind of comes into play with that this geometry. And so, for example, when I ask a face, give me your surface, it's going to return one of these kind of objects that then I can query and get more information. So if it returns a cylinder, then I can find out, what the orientation is and diameter of the cylinder. And then there's this mesh manager on the BREP body, and that lets me get basically a triangle representation of the body. So the real body exists as well-defined surfaces, so like say cylinders and planes, but I can get an approximation of that as a set of triangles. And so a lot of products, that's what they use, especially rendering, is they approximate the model using triangles. And so this supports getting that. All right, this next section on the object model chart is for assemblies. And so it has the ability to create joints. So most of the stuff that's in this, so you can create joints, joint origins, as-built joints, rigid groups, and you can drive joints. You can't do the other stuff that's on there yet, but so I can work with joints. And probably the most important part of what you see here is this little section that drawn the box around, this occurrences. And what that lets me do is traverse the assembly tree as you would see in the browser. So I can get this top level component, and then I can find out what other components have been placed into it, and then what components have been placed into each of those. So I can traverse the full assembly structure using those few objects that you see there. And then sketch, which we've already looked at a little bit. So here are all the sketch related objects. So I have the sketch curves, which we've talked about, and also the sketch dimensions, and the geometric constraints are all available here. But one thing I wanted to talk about in a little more detail is this profiles. And as you draw inside Fusion, so if I draw these two shapes inside a sketch, Fusion is automatically looking and finding closed planar areas as you draw. And by default, Fusion will show those as filled in as you close an area. And so it'll automatically do that. There's a setting so you can turn that off. But so if I draw these two shapes, I would see them fill in as I draw them. And those are known as, well, the shapes themselves aren't profiles, but what gets calculated. So Fusion with those two shapes ends up calculating 3 different profiles. So there's one profile, there's another profile, and there's another profile. And so the API provides access to these. So if I draw those two shapes and then I query the sketch and ask and get the count from that profiles collection, it's going to tell me that there are 3 profiles. And then from each profile, I can get which curves, so what is the shape of the profile, so what are those curves that define the shape, and then which sketch entity is used to define that. So for example, this triangle at the bottom right picture one, so that top line, there's one sketch line that's defining that, but in the profile there are 2 separate segments. And so when I query the profile, I would get those 2 separate segments, but then I could find out that they depend on that one sketch line. So anyway, I can, using all of that, I can draw shapes through the API, and then I can interrogate it to find which profiles I want to use to then use as input to create a feature. So it's the same kind of thing that the user's doing, but he's just visually picking what he wants. But through the API, you have to do some more querying to be able to figure out, logically which shapes you want to use as input. And construction geometry, this final box over here, the green box. And so this lets you, of course, get access to and create new construction axes, planes, and points. And here's a good example. I mentioned earlier that there was that definition object that I kind of skipped over. And you notice there's a lot of definition objects here. And what these are used for is a construction axis can be defined in a lot of different ways. And that's what a definition object is used for, is I have a single construction axis object, but then from that construction axis object, it will return a definition, and it would return one of these definition objects that you see listed here, depending on how it's defined. So, you know, if it's, let's go to construction plane. So if I have a plane at a distance, or construction plane offset, so if I get a construction plane and it's been created by offsetting from another plane, so I can go to that construction plane, I can ask it, how are you defined? And it would be by an offset, and then I can get that offset definition. And then that would give me the original plane that it was offset from, and it would give me the parameter that's controlling that offset distance. But if that plane was created by 3 points, then when I get the definition, I would get a 3 points definition, and that would return the 3 points that control the orientation of that construction plane. So I have always, so there's only one type of construction plane, but it can be defined in different ways. And so there's these different definition objects that get returned from that plane that give me the data, that tell me how it was defined, and then give me access to the data that controls that. So that's where definition objects are used, is when a single thing can be created in different ways. And then rather than build another slide, just there's one other area that I hadn't pointed out yet on the chart, is there's some API utility objects to do some kind of math related stuff, so matrix and vectors, and then this bounding box. All right, so this could be just a little bit confusing, and doesn't maybe not make a whole lot of sense initially, but there's this, all the objects in the library are divided into, or in the object model are divided into 2 libraries, core and fusion. And the reason for this is, at the time when we made this decision, which was very early in the design of the API, there's a core piece of software called Neutron, actually, and then Fusion is built on top of that. And the idea was that that core would continue, and there would be other applications built on top of it too. And so the core library is generic functionality that it was thought that a lot of these different kind of applications would use. And so it was separated into core, and then the Fusion specific functionality is in the Fusion library. And then the idea was, well, in the future there would be a CAM library, and so all these other libraries, and then would just be built on top of core. And so that's still somewhat true today. It's not, as a user, it's not always logical what would be in core and what would be in Fusion. And so just what I talked about. So to do that, to figure that out, it's just in the help. And although as I was just preparing for this, the help could use some help, because it's not really called out explicitly, and I'm going to add that for the next release. But so the way to find out what library something is in is to go to the topic for that function, and then go to the C++ tab for the syntax. And on that, so this include statement is going to have a path, but the first part of that path is which library it's in. So it's going to be in Fusion or Core. And in the next release, right up at the top, I'm going to have above this parent object thing is I'm going to say which library it's in. So it'll be in your face, but so all the functionalities is in one of the two libraries, and in a lot of cases you don't have to care because like in Python and JavaScript, the libraries are just imported and they're all kind of merged into the main namespace. So you can just use all the objects and you don't really care where they came from. But there's some cases where you do have to specify out the kind of the full path to that object. And so you do have to know which library it comes from. Static functions. So we've been spending all this time on the object model and how it's all structured. And so to get to a particular object, you have to know, what the ownership is, so you can jump from one object to another to get to a specific object. And static functions, you don't do that. You just create an object. But what that means is that the objects that you create statically are what we call transient. So they're not owned by anybody, and they don't exist inside Fusion. You won't see anything get created. It's just an API only object that's used usually as input for something. So it's a temporary thing that you use just to collect up some input to provide to something else, or it's used to return some data from something. And so there's several functions that are static that you can create that way. So you just create them directly without having to traverse anything. And in the help, it is specified that whether they're static or not. And then this shows in Python. So it's creating a point 3D. And so this is a case where you have to know the library. So we're actually, everything exists in space, and then we're going to the core library, and then the name of the object that I'm creating. So I'm creating a point 3D, and then point 3D supports this create method. And so that's the thing that's static, is the create method is a static method, and it takes in the XYZ coordinates, and then it creates a point 3D object and returns that, and then I can use that for something else. So here's an example of where it's actually used. So I have the circles collection. I'm calling a method on that collection to create a circle by center and radius. So this is a sketch circles collection. And so to specify that center, I can input a coordinate. But that, if we look at the help for this, that first coordinate is expected to be either an existing sketch point or a point 3D object. So if it's a point 3D object, then I'm just giving a coordinate point in space. But to input that point 3D object, I can create it using this static create method, and then the second argument is just the radius, and then it creates it. So this is, like I say, just specifying the XYZ coordinate. So it creates the point 3D object, passes it in, and then it's just all gone. Selections. So frequently in your programs you'll need some input from the user, so you're going to ask them to select something, and there's a few ways to get selections, and we'll go into a couple of more detail on Thursday when we talk about commands. But so one of the ways is I can get whatever is currently selected when the user runs my script. So maybe my script depends on the user having first selected some edges, and then I run the script, it finds those edges and then creates a fillet, for example. And so from the user interface object, there's this active selections property that will return a collection of what's currently selected. And I can also, in a script, just do this really simple selection where I just call this function, the first argument is a string, the prompt, and then the second one, and these are listed in the help, what's available, but it's a filter. So I want, in this case, the user can only select faces, and then it returns back a selection object. And then I can also create a custom command that prompts the user to select some things. But what I want to really talk about here, and this is I think where it's easy to maybe get stuck a little bit when you're writing something fairly simple, is selections in all of these cases are returned as a selection object. So I don't, in Inventor, if you'd used Inventor, if I do a selection and the user selects a face, I get back that face. And here I don't get back that face, I get back a selection object. So, but if I want the face, then on that selection object, I just call the entity property. And so that returns the face or whatever was actually selected. Okay. But the reason for this selection is I get back what was selected through this entity property, but I also get more information. So it's useful because then I get back the actual point where it was located. So I might want to use that for something. And then in the future, we can add additional information. Maybe there's some context of how it was selected. Was it selected in the graphics window, or was it selected in the browser? That's not there right now, but by having this selection object, we can do more in the future, and it does more already. It's just, I got caught on this a lot initially, is I would take the selection, the thing that was returned, and then start using it like a face, but you have to get the entity from the selection first before you can start doing stuff with it. Another thing that's people get confused with in using the API is an object called a value input. And so this is a statically created object. Again, so it doesn't represent anything inside Fusion. Basically, all it is, it's an API object that wraps a value, so a double value, floating point value, or a string. And so in Inventor, we had the ability to have what's called a variant. So it was a type that could hold any kind of value. So it could be a string or an object or a double or an integer. And here we don't have that because we're basically, the API is limited by whatever C++ supports. And so we need, but there's some cases that I'll show you in just a second where you can supply either a floating point value or a string, but we needed a way so that you could do one or the other. And so this class exists as a wrapper for one or the other, and then you provide that as input. So the way you do these is there's two methods on the value input object. These static methods, create by string or create by real. And so in both cases, it creates a value input object, but in one case, the data inside that's going to be a string. In the other case, it's going to be a floating point number. And where these are used is when you're creating something that's going to result in the creation of a parameter. And here's an example. So this is creating an extrude. And so I have an extrude input, right? So this, remember, an input object is kind of the equivalent of the dialog, so the extrude dialog. And we want to create an extrude that's a certain depth. And so this is defining that. So we're going to create a distance extent, and I have to tell it what the depth of that extrude is. And so this second argument is a value input, because I can define the depth in two ways. Is through the API, I can specify it by a real number, and we'll talk more about this in next week. But internally, the length unit for Fusion is centimeters. So here I'm going to create it by real, So I'm just saying a 5 for floating point number, and I create a real, and so that's interpreted as 5 centimeters. So if I've computed the value of this extrusion, so I've got some kind of formula and I've computed what the distance is, and I have that as a double, then I can just input it here and then I'm done. And so that'll create the extrusion. It'll automatically figure out what the parameter value is for that and create the parameter. But the other case is when I'm creating an extrusion, I can type in some kind of equation for that distance too. So in that case, I need to be able to define a string. So here it's doing the same thing. It's calling the set distance extent, but the value input is created by a string. And in this case, length divided by 2. So it's assuming there's a parameter that already exists called length. And so it's just creating that expression, that formula that it's going to use when it creates that parameter for that value. All right, so then close to done here. And so there's some, so when I got started with Fusion, there were some things that I found to be pretty different than what I was used to with anything else. And so one of these is that the file storage is on the cloud. So it's, sitting on A360. And so as a result of this, there's no local storage. So you can work offline, but the fact that the files are temporarily being stored local is kind of hidden, and you don't really have access to that. So for all practical purposes, there's no local storage, and there's no file management because Fusion is handling it all in conjunction with A360. So no file management is needed and not really even possible. It forces you to use A360 and the cloud. So that something was a little different to get used to. And when you use Fusion and designing, I mean, it's very flexible. Some would say maybe too much sometimes, so it can get a little confusing and you can build a little bit of a tangled mess. But in other cases, it's nice just because of the flexibility you have. So you have a complete design in a single document. So I've got, I can have an assembly and all of the parts and the sub-assemblies and everything exist within that single document. And as I'm building up that model, I can reference anything to create anything else. So I could have a part that's 3 levels deep in a sub-assembly, and then I create a sketch on one of the faces on that part to build an extrusion that's in some other sub-assembly, 3 levels deep. And so it's very flexible that way. So everything exists in one. I just use whatever to build whatever. But like I say, that can get a little bit confusing too. And then also, there's not really a distinction between a part and an assembly. So I talked earlier about components. And so a component can have bodies in it or parts, and then it can also have sub-assemblies. So there isn't really a distinction of what is a part or what is an assembly. I think most people tend to use it in a way, though, that so maybe you have a component that just has bodies or you have a component that just has sub-assemblies, but it doesn't have to be that. And then this new distributed design that was recently added, so that's more of the traditional method of where it's not in a single document. So you can create models and then reference them in to a model, and so then it's not quite as flexible because you've got stuff that is segmented into a separate document. So with this new distributed design, then it is more of a traditional way of looking at it. But all right, and then just couple things to finish up with. So add-ins versus scripts. So there's not really that much difference, and so it's be fairly easy to start writing a script and then convert it to an add-in. In fact, that's what I'll do sometimes because it's a little bit easier to debug a script than an add-in, at least with Python. All right, so scripts. So you run those from the scripts and add-ins command. So if I have a script and I want to run it, I have to run the scripts and add-ins command. The dialog pops up. I find the script I want to run, click it, and then say run. So it's a few steps to be able to run a script. And the script runs, and then it's done. And scripts can do commands. In fact, a lot of the sample scripts that come with Fusion, when you run the script, it has a custom command that it creates and runs. So for example, the spur gear sample, when you run it brings up a command dialog, gets the input, you click OK, it creates the gear, and then it's done. So you can do commands with scripts. And add-ins. So add-ins, you can have those automatically run at startup. So instead of the user having to go scripts and add-ins, you can define those so that Fusion will look for it when Fusion is starting up. It'll find the add-in and it'll run it right then at startup. And then it continues to run throughout the entire Fusion session unless the user explicitly goes into the scripts and add-ins and stops it. Right. So what typically happens is it's running at startup. You don't really want it to do anything then. I mean, it can't go and build models or anything. But what it will do is at that startup time is it will create whatever commands it has. Could be one or many commands. And then it uses the user interface part of the API to go and add its commands into the UI. And then it just sits back and waits for events to tell it when its commands have been created, and so then it can do whatever it does for those commands. And so if you're delivering something on the Exchange store, you almost certainly want to create an add-in, because then to the user, when I get an add-in and install it on my machine, it looks like just new Fusion functionality. There's just a new command that shows up. I just execute it by going to the toolbar, clicking that command. It runs like any other Fusion command. So it looks, like say, just like new Fusion functionality. Where a script is harder, and it's not obvious even that there's something new there to a user. And so scripts would tend to be things you write for yourself that maybe you're not even using all the time, some functionality. But if it's something you're delivering to somebody else, you really want it to be an add-in. I don't think there's really a restriction that you couldn't deliver a script through the Exchange store, but an add-in is going to be a lot nicer for the user. All right. So one more thing I wanted to just touch on, I think this is the last thing, is code hints. So when you're writing code and with derived classes, it can be you tend not to get a lot of help from the code hints inside the development environment. And so here's an example. And so I have typically what will happen is from the application. In fact, I've got some code. Well, we'll go look at some code in a second. So from the application, I would generally call, give me the active product. And if we look at the active product property, it returns a product object. And a product is this base class that represents like design data or drawing data or CAM data, right? Right now the API only has design, but so it's the base class for all these things. So you can see design is derived from product. So if I ask the application, give me the active product, it's defined to return a product object. And product, you can see here, doesn't support a whole lot of stuff. And if I ask for the active product and I'm expecting a design, it's most likely I want to access some of this stuff that's specific to design, especially you can see here there's the root component property. So then that's going to give me access to all the interesting stuff, interesting Fusion stuff in here. But with IntelliSense or the code hints, it just thinks I have a product, so it's not going to give me all of the interesting stuff that I can get. And so let me just demonstrate that real quick. And we'll use that script we did on Tuesday, which doesn't have much. So you can see here, once it displays.
I think you may have to.
Yeah, I'll wait a minute. In fact, it looks like it's really slow. There we go. Finally, it's starting to appear, I think. All right, so this explain what this program does, and then once it's everybody can see it, I'll go in a little more detail. So this is the program I demonstrated very quickly on last week that just creates a new sketch and then adds a circle to that and puts a diameter dimension on it. Right. And so on the first line, it's calling addins.core.application.get. So that get function of the application object, so that's a static function, and that gets the application object and returns that. So now, in Python and JavaScript, you don't type variables. So we're not telling Python at all what any of these variables are, but the IDE is doing some inferring to figure out what things are, and it knows about the Fusion API and how it's defined, so it's able to do actually quite a bit of inferring and give us some decent code hits. So for example, here it knows that the get function on the application object returns an application object. Right. So if I now do app dot, so now it's correctly showing me all of the properties and methods that the application object supports. So it's figured that out. Okay, but now on this next line, it's calling app.activeProduct. And as I just said, active product is typed in the API definition to return a product, but I'm expecting a design back. But so if I do a design dot, now it's just showing me the properties that a product supports, because that's all the IDE can figure out, is because active product returns a product, and so that's what I'll show you. But I want to be able to get access to all of the other stuff. In fact, I do have access to it now. It's just that code hints aren't going to tell me what I want. Because if I run this program, it knows that design is at runtime. It knows that design is really a design and not a product, and so I can call properties on it and everything's going to work fine. But when I'm typing my code, I don't know that design supports root component because it's just showing me that there's stuff that's on a product. And so to work around that, in both it's done slightly different syntax-wise, but it's the same kind of thing in JavaScript and Python. Is I can help the editor know what to expect. So I can do ADSK dot fusion dot design, and then the design object supports a method called cast, and I'm going to pass in the result of this active product. And so it hasn't changed how my program behaves in any way, but now because of this call to cast, the IDE knows that design is a design object, because that's what this returns. It returns a design object. And now if I do design dot, now I get all of the stuff that a design supports, instead of just seeing what a product supports. So that's just a little tip on using these, and because if you've used Visual Studio and C# or VB or whatever, you get really dependent on these code hints. Because now if I let's see, well, even if I do cast here, because it shows me the arguments that I need, and so it gives me a lot of help, what's available, and if I have good code hints, then I spend less time looking at the help to figure out what the arguments are. All right, and I want to spend just 1 second, a little bit on help to help you understand a little better what's there and to use it more effectively. So it's divided up into several sections. So there's this user's manual, and those are overview topics. And so it's good to look at those. This section will grow over time. There's already some stuff that should be there that's probably not, but it's just a matter of having time to write it. Then there's this reference manual section. So that lists all of the objects and all of the enumerators. So every object is listed here alphabetically. And so here are all the methods and properties that object supports. If I click it, and it lists them over here. And some information here is it shows me what object this is derived from. So this one is just derived from the base object, which everything is derived from. And then it also, this is something new in this release, it shows me where this object is accessed from. So this is giving me some hints about where it is in that object model chart. And so this object, an as-built joint, I can get from, there's a function on an as-built joint called create for assembly context, also a native object, but here's as-built joints add. So if I create a new as-built joint, that's going to return an as-built joint. And then the item on the collection and item by name on the collection. So these are all functions that return an as-built joint. And then at the bottom, if there are any samples that demonstrate that particular object or method or property, then that's going to be listed. And if I click on that sample, then it'll take me to sample code, and it should be most of the samples have JavaScript, Python, and C++ codes, and you should be able to just copy and paste that in and run it. Let's see what else was should drive. Oh, the syntax samples. So if we go to a particular function, then at the top there's these syntax samples. So it has tabs, so I can look at it in Python, JavaScript, and C++. And so this shows me a valid call of that. So it's not a full sample because it hasn't set up the variables that are being passed in, but it does show me really how it could be called in these different languages. All right, so I think just the upcoming sessions. So today, this object model. Thursday, we'll talk about commands. Next week, assembly structure, and then model geometry. And these next three are based on just what you want to hear about, what topics we think are still relevant. And so that's it. So if there are any questions, and so you can use the little icon to raise your hand, or you can type them in.
I think you may have to share your PPT. We are still seeing the all right, yeah.
Okay, yeah, I don't know why it's so slow today. All right, let's see. So there's a few questions here. Let me. So first, is the export manager the same thing as import? So probably just before. So I kind of covered that. There's separate ones. So there's export and import. Let's see. And Justin's left, so I'll maybe skip that. Well, he asked, is it possible to export documents without having to individually open each one? But no, I mean, Fusion has to know which document. You have to open it before you'll be able to export it. You only have access to that data when it's open. Then there's a question, when is the next update? And there'll be one in November is the next big update. And the question of where can we find the list of static functions? And there isn't a single list of the static functions. They just so they exist as a method on a particular object, and so they're documented, as a method on that object. So there isn't a list, a single list of all the statics. It'd be possible to create one. Hadn't thought of it before, but. All right, any other questions? Or even just comments, ideas on those open sessions still that we should cover? Or? All right. Well, I hope this is helpful, and I really would like your feedback because we're doing this for you, and hopefully to make this a little less painful. And so please let us know what would be better or what's helpful. And so you've got tomorrow we'll have another just Q&A session. So those that attended yesterday, it's just an open session to ask questions. There's no planned presentation. And then you can always send email to the, was it Fusion 360 Hackathon at Autodesk.com and get help through there. So, all right, well, thank you for attending and have a good day.